So raise your hand if you have some money in at least a bank, at least one bank somewhere. A lot of you have money in a bank, right? And even if you don't have money in a bank, someone's got money for you in a bank, right? When I was younger, my parents put money in a bank so that when I went to college, I could use it. And that's what happened. When I went to college, I had some money that I could use. Okay? So some of you, I'm sure, have the same type of thing. Here's my question. My question is, why do we put money in a bank? Why do we put money in a bank? What's one reason why? Yeah. Interest is one thing, right? Interest, right? What is interest? So if you're explaining interest to somebody, what is interest? Like someone that's never heard of interest. What is interest? How do I describe interest? To what? You're right. Keep going. It, it could be like that, right? Credit cards, right? Credit cards have interest, right? If I'm using a credit card, if I go and buy a TV at Best Buy or Target or whatever, and I use a credit card, Costco, I use my credit card, right? TV costs $500. When I got to pay back the credit company, right? That's who they give me a loan. It's a mini loan they give me. When I pay them back, I don't pay them back $500, right? I pay them back 500 plus interest. That's how the credit cards make money. Okay, that's one way. Same thing with a car loan, right? If you buy a car, most people don't have $20,000 for a car, right? Or more. It depends on what car you have. But you go to the bank and say, "Hey, I would like to buy this car. Can I have this amount of money to borrow?" Bank says yes or no, depending on whether they think you can pay it back. And then you pay it back. So you don't pay back $20,000. You pay back more than $20,000. Okay. What's another type of interest though? What's the type of interest that affects you guys in a bank? Hmm? Exactly. Yeah, that's one of the reasons why we put money in a bank is because the bank will give you money. They will give you free money. You put money in the bank, they'll give you free money. Okay? Sometimes every day, sometimes every week, sometimes once a year. Just depends on what kind of deal your bank has. It's called interest. Okay, just for keeping my money in your bank, you'll give me money. That's one reason why. Definitely, that's important, right? What's another reason why having money in a bank? Why we put money in a bank? It's safe. Yeah, it's safe. It's saved. It's not. You don't have. You know. You could buy the biggest, fanciest safe ever made. Put money in there. I could all my cash in there. Thing could be stolen, right? It could be stolen. You just don't know, right? So it's safety, right? So I have a question. Let's say I put money in a bank account. Bank gets robbed. It's happened before. I'm sure the money you have, I'm sure the bank you have money in has been robbed before. Same thing has happened to me. I wasn't in there, but my money, the bank got stolen, right? The bank got robbed. What happens to my money? What happens to my money? Let's say I have $500 in there. They took it. They took $500 plus more, right? They'll probably get caught later on, but let's say they spent it before they got caught. What happens to my $500? It's not actually gone. It's not actually gone. What happens is the federal government will insures it. It's called the FDIC, Federal Deposit Insurance Commission or something like that. Every bank has to be a part of it. What it says is if the bank gets robbed or if the bank makes bad decisions, business decisions, and it goes bankrupt because banks do go out of business, your money is safe up to like $100,000. Okay, so that happened. Most of you guys are juniors. It happened. Why did that happen? Exactly. 1929. What happened in 1929? Black Tuesday. Crashed, right? Stock market crashed. Everyone lost money. First thing people did was, I need to go run to the bank and get my money, right? I lost my job. I lost all this thing. Banks were like, sorry, we don't have your money, right? So the federal government said, no, we can't have that anymore. That's not right. These people didn't do anything. It was the bank's fault. So they created the FDIC, which says up to a certain amount, the federal government. So if your bank gets robbed, you're going to get your money back. Don't worry. So God forbid if you're ever in a bank and it gets robbed, don't do anything, right? That's why they say don't do anything, do whatever they ask, because your money's insured. Your money is taken care of, right? Even if they take every single penny in that bank, you'll get it back. Don't worry. Okay. Um, yep, those are the reasons why we use banks, right? Those are the reasons we use banks. That's what we're going to talk about today. We're talking about interest. Interest, right? How do banks make money, right? They give me money to pay. So I put money in my bank. They give me interest, even if it's a couple bucks. Still, that's a lot of money because they got to give it to everybody who has money in that same bank. Talking about millions of dollars. How do they get that money to pay? Exactly. That's how banks survive. Banks do two things. They house your money and they give loans out. Okay? They make money by giving loans out. Car loans, house loans, personal loans, business loans, right? If a business says, I need some money to make it through this year. Once I get my business going, then I'll pay you back, right? Any of those types of things, that's how they make money. Well, banks can make bad decisions, right? In 2008, you guys were, pretty young in 2008, but in 2008, what happened was that's what happened. We had wasn't a Great Depression, but it was a recession. Banks were making bad decisions. They were giving home loans, right? People were saying, I want to buy a house. Okay, we'll give you a loan. They were giving home loans to people who shouldn't have a home loan, couldn't pay it back. So the banks were out of money, right? So a lot of banks went out of business then, right? So it took a while for our economy to dig out of that hole. Um, so yeah, that happens. That does happen, even like I said, recently. So your money is safe with the bank because you trust the bank. It's a trust, right? Um, if you trust the bank, they have an obligation to not lose your money, right? Or if not, the federal government will come in and say, "Here's your money, give you a check." Okay. Okay. So how do we calculate interest? Any kind of interest? Well, we have two formulas. Okay, it's called compound interest. We have two formulas. Most of the time, we're going to use the top formula. Okay, the bottom formula we're only going to use if they tell us it's compounded continuously. If they use the phrase compounded continuously, we use this formula down here. So what is compounded? What does it mean to money to be compounded? Interest to be compounded. It's how many times do they put money in your account, right? How many times do they run that formula to put money into your account? Some banks do it every day. Some banks do it once a week. Some banks do it once a month. Some banks just do it once at the end of the year. Just depending on your bank. Okay. All right. So we got a lot of letters here. So let's write what each of them means. Okay. So A is the amount of money, amount of money. Usually the final amount, but that's why it's A. It's amount of money. Okay. P, right below it. P is also money. But the reason it's not A and it's P is because it stands for principal. Principal money. It's a principal, not like the principal of a school. It's principal money. Does anyone know the difference between principal money and what is principal money? Does anyone know? Principal money, yeah, go for it.
Principal money, like you're in charge of the money kind of?
Kind of, sort of. Principal money is what you start with. So if I want to start a business, I need money to start the business. So you get principal. I have money to start it with, right? Or I have investor. I have someone who's investing in me. They start me out with money, right? That's principal. Okay. So if I open a bank account, I open it up with principal, right? I can't go to Bank of America, Citibank, and say, I want to open a bank account and not have any money, right? They'll say, come back when you have money. That's the principal. Okay. R is interest rate. Interest rate. Interest rate. Okay. We always write interest rate as a decimal. No percentages. They'll usually give us a percentage. We want to change it to a decimal. We'll talk about how to do that. Okay, we don't want a decimal, or sorry, percent. We want it with no percents. N. N is the number. N is the number, not hashtag, number of times interest is compounded per year. Per year. The number of times interest is compounded per year. How many times a year are they putting money into my bank account? Right? Sometimes, like I said, it happens. Sometimes it happens as fast as that. Money in the bank, money in the bank. That's continuously, right? Sometimes it happens every day, daily. Sometimes it happens once a month, monthly. Sometimes it happens quarterly. Quarterly is every 3 months. Okay, they'll tell us. They'll always tell us that. T is time in years. Time in years. How long are you planning to keep the money in the bank? The longer the better. If you want money, the longer the better. E is not a variable. Okay, E is not a variable. E is actually a number. Okay, it's around, let me write this down. What is it down? It's around 2.71828, and then it continues on and on forever and ever and ever. Okay, it's a number that banks use when your money is being compounded continuously. Okay, they only use it when it's being compounded continuously. When it's not, they don't use it. So anytime you see E from now on, it's not a letter. It's not like X or Y. It's an actual number. It's kind of like pi, right? Pi is 3.14150. It goes on forever and ever and ever. It's the same thing. You have an E button on your calculator, okay? Just like you have a pi button on your calculator. It's the same. It means the same thing. Okay. All right. So when we're doing these problems, so we'll start at number one. When we're doing these problems, we have 4 steps. First, label what's given, label what we need, which formula are we going to use, and then plug it in and solve it. Okay, so number one. Tanya invested $390 into an account that pays an interest of 2.7% compounded daily. Assuming no deposits or withdrawals, that means she leaves the money in there and never touches it. Doesn't put any money in, doesn't take any money out. Leaves that $390 for 18 years. How much money to the nearest cent would she have at the end of those 18 years? That's what the question says. Okay. So first step, what do we know? Okay, so these are the things we're going to know or not know. Right? Those look familiar. They're from A is amount, P is principal, N is number of times compounded, R is the interest rate, T is how long. Okay, so we're going to fill them in by what we know. So we have, first thing we have is $390. Which one of these letters does that go with? Which one of the letters? A, B, A, P, N, R, T. P, good. It's P, not A. Not A, yeah. It's P because that's how much she started the account with. That's starting value. That's her principal. A is the amount after 18 years. That's what we're trying to figure out. So A is actually what we're trying to figure out. Okay. Hmm? Well, when we get there, we will, yeah, well, let's go in order. N, the number of times they're putting money into her account in 1 year. So how many times is it being compounded? Daily. So if it's daily, how many times at the end of the year is money going to be put into her account? 365. Okay. R is interest rate, 2.7. That's a percent. We don't want percents. So how do I change 2.7 so that it's just a decimal, no percent? What's the trick? Anyone remember the trick to use? There's two ways to do it. There's a trick and there's a way using the calculator. What's the trick to change 2.7 to no percent? That's the way using the calculator. Yeah, you take 2.7 and you divide it by 100. That works. What's the trick though? It'll always do what? Yep, that's the trick. Yeah. Either divide it by 100 or just move it two spaces to the left. So 2.7% becomes 0.027. Either one, I'm okay with. So if you don't know, divide, and you'll get 0.027. Okay? And then T. Bennett, what is T? 18 years. That's how long she's keeping the money in. Okay? Step one, step two, we know what we know what's given. We need to find A. So which formula are we going to use? Are we going to use the top formula or the bottom formula? Top formula or bottom formula? Top. Yep, top, because it's compounded daily, not continuously. There's no continuously. So we're going to use the top formula. Okay, so let me rewrite it. Okay, just rewrote it from the top. The next thing we're going to do is fill in what we know. Fill in what we know. We know P. P is $390. Okay. 1 plus R, we know what R is, 0.027. We know what N is, 365. We know what N is, we got to write N again, times T, which is 18. And we don't know what A is, so we'll keep A as A. That's all the work I need to see, because the rest, your calculator is going to do it. Your calculator is going to do the rest. But trust me, calculator is where people go wrong. It's not this. You guys can do this really well. It's the calculator, because when you want to put things in the calculator, sometimes the calculator doesn't give you the answer you're looking for. Yeah, yeah. Okay. So I'm going to go through step by step to show you how to use the calculator on this. Okay, so get Delta Math ready. Get the calculator for Delta Math ready to go. All right. Okay, so the first thing I'm going to do is I'm going to do the exponents. I'm going to multiply the exponents first. Right? I'm going to multiply the exponents. So 365 times 18. Okay. 6570. I'm not going to write that stuff down. I'm not writing it down, but I have it in my calculator. Okay? The next thing I'm going to do is the inside, the parentheses. The inside. This part here, this part right here, the inside here. Well, before I add, I got to divide. So I'm going to divide these two numbers here, and then I'm going to add 1. Okay? So let me divide. 0.027 divided by 365. And then I want to add a 1 on the outside. I'm going to add a 1 on the outside. You can put the 1 in the front too, but just like it is on my paper, right? That's what I would get inside the parentheses. 1.0000073 forever and ever and ever, right? It doesn't stop at 3. My calculator just said, I'm not writing any more numbers. I'm done. Okay? So what we're going to do now is we're going to take this number to that power. We're going to take this number to that power. This is how we're going to do it. So the power is 6570. So I'm going to write that down, 6570. I'm going to need another line. My calculator remembers the previous answer. It doesn't remember any of the other answers. It remembers just the last answer. So see the button right here that says answer ANS right above ABC? You're going to push that button, and that's your previous answer. We want to take that number and raise it to, so you're going to raise the power, right? Shift 6. Shift 6 makes a power. You're going to raise it to 6,570 because that was 365 times 18. There you go. 1.625770774. Not done yet. What's the last thing I got to do before I can get my answer? Times it by 390. Times it by 390. So I go 390 times my previous answer. That's the number I'm going to write down. 634.060506. Okay, so let me go back to my notes. Then they said, okay, round it to the nearest cent. Which number there represents the cent, is in the cent position? Which number here is in the cent position? Not 0. 5 is in the cent position. 0 is in the 10-cent position. 5 is in the cent position. So to see if we round up or stay there, we look at the number right in front, right? Or right behind it, sorry. 0. So does 0 tell us to stay at 5 or go up to 6? Stay at 5, yep. So our answer is 634 and 5 cents. Telling you right now, most of the mistakes I've seen are calculator errors and rounding errors. Right? It kind of is. It's funny, right, that the hardest part of today is the calculator. Because I guarantee you I'm going to have, how do I do that? How do I do it on the calculator? Right? That's the hardest part about today. It's not the math, it's the calculator. Okay, so you got to learn how to use the calculator to get it to do what you want it to do. Calculators are great, but they're tools. They're not going to do the work for you. Like I could have the nicest hammer ever made, but it's not going to build a house unless I actually do it. The same thing with a calculator. Okay? All right, so let's go to number 2. Okay, so number 2, I want you to do this. If you haven't already done it, what do I know? What do I need? Always start that way. What do I know? What do I need? Read it, underline it, circle it, write it down. What do I know? And what do I need to know? Okay. 60,000. I have 60,000 so far. What does 60,000 represent? P. Good. Not A. It represents P. Good. N. N. How many times is it being compounded in 1 year? 4, because a quarter is 4, right? 4 quarters in a dollar. That means 4. Good. R. How do I write 4.7% as a decimal? There you go. 0.047, right? Move the decimal 2 places to the left. Okay. T, how much time are they keeping the money? Is Austin keeping the money in the bank? 11 years. Good. So A is what I need to find. How much? Which formula am I going to use? The top one or the bottom one? Same one I used last time, right? Top one. Okay. Next thing, last thing, plug. Plug in. I have 0.047 times, move this over a little bit, times 11. Okay, that's all the work I need to see. Once you have that, that's enough work for me. I'm happy. Now you got to go to the calculator though. Now we got to go to the calculator. And like I said, most of the mistakes I see are calculator related or rounding related. Okay. So when we go to the calculator, we're going to do decimal or we're going to do exponents first. Okay. So exponents first, then parentheses, and then take it to a power. And then the last thing we're going to multiply times 6,000, 60,000. Okay. So okay. So my decimal, my exponent is 0.047, and then I'm going to multiply that times 11 years. Yeah, 4 years. Oh, yeah, 4 years. Why did I write 11? I don't know why. Thank you. Oh, sorry. So 4 times 11. Okay. 4 times 11. Thank you. So it's going to be 44. Okay. All right. So now I'm going to do the inside, the parentheses. Inside the parentheses. So I'm going to do division first, add +1. 0.047 divided by 4 plus 1 on the outside. Then I'm going to take that previous answer, that answer I just came up with, and I'm going to raise it to the 44 power, because that was 4 times 11. Last step, I'm going to take that answer and multiply it times 60,000. And that's the number I'm going to write down. The same number you have on yours. It's the same number you have on your calculator. This number right here. $100,316 and about 56 cents. Okay. If I put that answer in Delta Math, though, they would say it's wrong because I didn't read the directions to the nearest $100. So which of those numbers is in the $100 position? Which of those numbers is in the $100 position? 3. Yep, 3 is in the $100 position. So I look to the right to see if I raise to 4 or stay at 3. So the number to the right is 1. Stay. So watch this. 1, 0, 0, 3. Everything else turns into a 0. Everything else turns into a 0 because that's rounded to the $100. Not the nearest cent, $100. Okay? Make sure you read that because I know I'm going to get questions about it and say, I think I did it right. I think Delta Math is wrong. No, it's not wrong. Just got to go back and read directions. Okay? All right, we're going to do 2 more and then the last one we'll leave for tomorrow. All right? Okay, so number 3. Label A, label P, label N, label T, label R. First thing you're going to do is label all of those guys. And then tell me which formula we're going to use. I'll give you about a minute or 2 to do that. Okay, so Hannah invested $820, pays her an interest rate of 1.8% compounded continuously. Assuming no deposits or withdrawals are made, how much money to the nearest $100 will she have after 16 years? Okay, so 16 I know is here. Interest is going to be 1.018. N, what is N? N, what is N going to be here? Yeah, can I put a number on continuously? No. So when I can't put a number on continuously, that means I have no N. So if I have no N, what does that mean? Exactly. We use the PERT formula. Compounded continuously means I use a different formula. Okay. 820, is that P or A? P. Good. A is what I'm trying to find. Okay, so we're going to use E this time. We haven't used E yet. It's okay. It's like the numbers on your calculators, the letter or the number E. It's weird saying the number E, but that's actually true because it isn't a letter. It's not a variable. It's a number. Okay, so go to the calculator. It's right above the D. Okay, here we go. First thing I'm going to do is put my decimal in. 0.1018 times 16. Okay. E. Here's the nice thing about using delta math. You don't have to find E. Just type in the letter E. There's E. From now on, E won't be a letter. It'll always be that number, 2.7128, whatever. Okay. So now what I'm going to do is I'm going to raise it to that power that I just calculated. So shift 6, previous answer. Okay. Last thing to do, take that previous answer and multiply it times P, which is 820. Oops. You get 1093 decimal 6809. 680989. Yep.
So with E, are you multiplying the exponents above? With E, are you multiplying 820 by E?
I'm multiplying. So what I did was I multiplied these two guys first, right? And then whatever this number was, I took E to that power. And then that answer times 820. Okay. This one says round to the nearest $100. So what number is in the $100 position? 0. This 0 right here. So the number after it is 9. Does 9 say we round up or stay there? We round up. So that number becomes 1, and everything after it becomes a 0. Since it's money, I'll stop with there. I won't go any more zeros because it's money. Okay. Okay, we're gonna do one more and we'll be done. Number 5 we'll do at the beginning of tomorrow. Okay, because the rest of them, the next 2 are a little bit different. Same steps, but step 4 is a little bit different. Okay. All right. So example number 4. Pick out what you know. A, P, R, N, T. Which formula am I going to use? Always start there. And then read the question and then figure out what we're going to do. So how is this one different than the ones we've done before, than the 3 we've done before?
There's no P.
Say it again.
There's no P.
Yeah, we're looking for P this time. A, they've actually given us. 46,000 is actually going to be A, not P. Yeah, how do we know that 46,000 is A and not P? What tells us that?
Because it says always to read for 46,000.
Yeah, well, they're asking us how much today. How much today does she need to go in the bank and give to and deposit so that in 13 years she can walk in the bank and say, "Where's my $46,000?" Okay, that's what she's asking them because in 13 years she's going to need $46,000. So it's changing it a little bit. So number 4 is going to change a little bit, not a lot, because we're still plugging in numbers. It's just we don't have P now. So my goal is to get P by itself. How am I going to do that? There you go. Division, right? Yeah, division, exactly. P is P times E. What's the opposite of multiplication? Division. So actually, you know what I'm going to do? I'm going to do this. I'm going to do that, but for right now, I don't want to multiply yet. I'm going to divide by what I don't want. And then I'll put that in the calculator. Anything divided by itself makes a giant 1, so that's a giant 1. So all that's left is 1p. Now my calculator is going to do this part here. So when I use my calculator, I'm going to do this part here and then divide it 46,000 on top. Okay? So multiply the exponents, then take to the power of e, and then 46,000 is on top. Okay, I'm going to go to my calculator now. Okay, so 0.038 times 13. Okay, I'm going to take that number. That's going to be my power. So e to that power. That's the number that's on the bottom of the fraction. That's the number that's here, 1.6388, all that number. That's the number that's down here, all at the bottom. So now what I got to do, my last thing is 46,000 first divided by answer. Okay. Four six zero 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 divided by answer. And there you go. That's the number I want. Zero six 068.31602. 31602. 280. 316. Okay. Okay. The question said nearest cent. This one said nearest cent, right? So what number is in the cent position here? 1. Yeah, that's the 1 after the 3. So I'm going to underline the 1. The number right after it is 6. So is that 6 say stay at 1 or raise to 2? Raise to 2. Good. So 28068.32. That's all I need to write. Since it's money, you don't have to put the zeros after it. Because money only goes 2 places past the decimal. Okay? So, real quick, don't pack up yet. We have plenty of time. We have one more problem. Again, the hardest part about this is the calculator part. That's the hardest part about it. The rest of it, you guys got. This over here, plugging them back in, which formula to use, step 1, step 2, step 3, you guys are fine. It's always the calculator part and the rounding part that always are the tricky part, okay? So make sure you're doing, when you use the calculator, make sure you're careful with it. Okay, because I've seen people put stuff in all the right numbers, but they put it in the wrong order, or I don't know what they do, and they get the wrong answer. And they're like, the calculator did it. I didn't do it. Well, unfortunately, I can't get the calculator a grade. It's a tool. Okay, so just be careful when you're doing that. All right. Okay, so fold this, put it in your notes. We will do number 5 first thing when we're in here tomorrow.